Does the future already exist? Relativity and the block universe. Does the future already exist at this moment? The present probably feels more real than either the past or the future. The past has happened and left its records behind. The future seems unsettled, shaped at least partly by decisions that have not yet been made. We tend to imagine the present as the boundary between them, moving steadily forwards as possibility becomes history. It is an intuitive picture of time, but it may not be the one described by modern physics. According to Einstein's theory of relativity, the universe does not possess a single present moment shared by everyone. Two observers moving differently through space can disagree about which distant events are happening now, and the laws of physics do not allow us to declare that one of them must be wrong. Without a universal present, the familiar division between past, present, and future becomes much harder to defend. Some physicists and philosophers therefore take relativity to support a radically different possibility. The future may not be something the universe is gradually creating. It may already belong to the structure of reality. To see how this idea arose, it helps to begin with the older view of time. For Isaac Newton, time existed independently of everything else. It flowed at the same rate everywhere, providing the universe with a single underlying clock. Whether someone was standing on Earth, traveling between planets, or falling towards a distant star, the same cosmic time was assumed to pass for everyone. Observers might disagree about where an event happened, but in principle they should agree about when it happened. There was one true present extending across the universe. Einstein's special theory of relativity replaced that picture. The theory begins with the observation that the speed of light in a vacuum is the same for every observer, regardless of how the observer or the source of light is moving. The statement sounds technical, but its consequences reach into the meaning of distance, duration, and simultaneity. Imagine a spacecraft passing Earth at an enormous speed. An observer on the ground watches a clock inside the spacecraft and finds that it runs more slowly than a clock remaining on Earth. The traveler notices nothing unusual. Their heartbeat, thoughts, and instruments all continue normally. From their perspective, it is the Earth clock that is affected by motion. Neither clock is faulty, and the difference is not simply an illusion caused by distance. Observers moving along different paths through spacetime can genuinely measure different amounts of elapsed time. At ordinary speeds, the effect is extremely small. At high speeds, or over long periods, it becomes significant. It has been measured repeatedly and must be accounted for in systems such as satellite navigation, where clocks in orbit do not remain perfectly synchronized with clocks on the ground. Time, then, is not a universal background against which everything else changes. Space and time form a connected structure known as spacetime. An object has a location not only in space but also in time, and the path it follows through spacetime determines how much time it experiences. Different rates of time are only part of the problem. The deeper challenge to our ordinary idea of the present comes from simultaneity. Suppose two flashes of light occur at opposite ends of a railway platform. An observer standing halfway between them receives both flashes at the same moment. After correcting for the equal distance the light has traveled, the observer concludes that the flashes happened simultaneously. Now imagine a second observer passing through the station on a fast-moving train. The passenger receives one flash before the other. After correcting for the distances involved within their own frame of reference, they conclude that the flashes themselves did not happen at the same time. The observer on the platform reaches the opposite conclusion. This is not a mistake caused by slow light signals or inaccurate clocks. It is a consequence of how space and time are related events that are simultaneous for one observer may not be simultaneous for another moving relative to them. There is no hidden universal clock available to settle the disagreement. The effect becomes more striking when the events are separated by enormous distances. Two people passing one another on Earth might agree about what is happening nearby, while assigning different presence to a world many light years away. An event on that world could belong to one observer's present and another observer's future. So which event is genuinely happening now? Relativity provides no preferred answer. This does not allow anyone to see the future or send information into their own past. The speed of light still limits which events can influence one another, and the order of cause and effect remains protected for events connected by a physical signal. The difficulty concerns distant events that cannot yet have affected us. Their placement in the past, present, or future can depend on the observer's motion. The universe described by relativity therefore appears to have no single objective now extending through space. For supporters of what is known as eternalism, the natural conclusion is that the present is not a fundamental feature of reality. Instead, space and time together form a four-dimensional structure containing every event. Each event has its own position within space-time, just as each place has a position on a map. Your birth occupies one region of that structure. The moment you're experiencing now occupies another. Events you currently describe as future would lie further along your path. This picture is often called the block universe. In a block universe, the past does not disappear, and the future does not wait to be created. Events at different times all belong to one complete space-time structure. A person would not be represented only by the body they have at this instant. Their entire life would form an extended path through space-time, known as a world line. The child they once were, the adult they are now, and the older person they may become would be different temporal parts of the same history. Human experience does not feel like this. We encounter one moment after another. Yesterday is remembered, tomorrow is anticipated, and the present seems to move continuously forwards. The block universe interpretation places that sense of movement within experience rather than within time itself. A comparison with space can help, although it should not be taken too literally. Jersey, London, and a distant star can all exist, even though you occupy only one location. Traveling from one place to another does not bring the destination into existence. Eternalism applies a similar idea to time. Occupying one moment does not necessarily make that moment uniquely real. Other times may exist even though we are not located within them. The difficulty is that time does not feel like another direction in space. We can move north or south, but we appear unable to choose a direction through time. We remember earlier events, but not later ones. A glass can fall from a table and shatter across the floor, yet we do not see the fragments rise, reassemble, and return to their original position. This asymmetry is known as the arrow of time. At the microscopic level, many of the basic equations of physics make little distinction between past and future. If a recording of two particles interacting were played backwards, the reverse motion might still obey the same underlying laws. Everyday events behave differently because they involve vast numbers of particles. An intact glass can be arranged in relatively few ways. Once shattered, its fragments can be distributed across the floor in an enormous number of possible arrangements. This difference is described using entropy. Entropy is often simplified as disorder, but more precisely it concerns the number of microscopic states that can produce the same larger condition. Systems tend to move towards states with more possible microscopic arrangements. Heat spreads, substances mix, and organized structures gradually break down unless energy is used to maintain them. The increase of entropy supplies a physical direction to time. It may also help explain why memory points one way. A memory is a physical record. Creating one requires changes in the brain, just as creating a photograph requires a change in a camera or storage device. Records are formed through physical processes that occur in the same direction as increasing entropy. We remember the past because the present contains traces of earlier events. It does not contain equivalent records produced by events that from our perspective have not yet happened. The difference between remembering yesterday and anticipating tomorrow may therefore arise from the physical state of the universe rather than from time itself flowing. Our sense of a moving present may also reflect the way the brain operates. It continually updates its model of the world. New information enters awareness. Recent events become memory, and expectations are either fulfilled or revised. From inside that process, it feels as though we are traveling forwards through time. The block universe interpretation offers a different description. We are not moving through a universe that is being created moment by moment. Different versions of us occupy different points along a world line, and each experiences its own moment as present. This picture appears to threaten the idea of an open future. If future events already have positions in space-time, then the choices we have not yet made may also be part of the structure. That does not automatically mean that everything is predetermined. Determinism is the claim that the complete state of the universe at one moment, together with the laws of nature, fixes what happens at every other moment. The block universe is instead a claim about which events exist. It says that past and future events may be equally real, but it does not by itself explain why those events take the form they do. Quantum mechanics makes the question more complicated. Some interpretations treat certain outcomes as fundamentally indeterminate. Others describe all possible outcomes as occurring in separate branches, while some preserve a more deterministic underlying picture. There is no single interpretation accepted by everyone. Relativity therefore does not prove that every event was inevitable from the beginning of the universe. nor does modern physics provide a simple answer to the question of free will. Even within a complete block universe, decisions would still occur through reasoning. Suppose that tomorrow you face a difficult choice. You consider the consequences, remember earlier experiences, ask for advice, and eventually decide what to do. If that event has a definite location in space-time, your deliberation would still be part of its cause. The decision would not happen despite your thoughts, it would happen through them. A complete history can still contain genuine reflection, uncertainty, and cause and effect. If tomorrow's decision has a place in space-time, your reasoning may be precisely what gives that event the form it has. For some philosophers, that is enough for meaningful freedom. You are free when your actions arise from your own motives, values, and reasoning, rather than from coercion. Others argue that genuine freedom requires more. The future must remain truly open until the choice is made. Relativity alone cannot settle that disagreement. Much depends on what we mean when we say that a person could have done otherwise. The block universe is also not the only philosophical response to the physics of time. Presentism holds that only the present exists. The past no longer exists, and the future does not exist yet. A second view, known as the growing block universe, proposes that the past and present are real while the future remains absent. Reality grows as new events are added at the advancing edge of time. Both views preserve some version of temporal passage. Their main difficulty is explaining what counts as the present in a universe where simultaneity depends on an observer's motion. Some philosophers suggest that a preferred present may exist even if relativity prevents us from detecting it. Others believe that future theories of physics may alter the question completely. There is currently no experiment that simply reveals whether past and future events exist in the same sense as present ones. Physics gives us mathematical relationships between events. Deciding what those relationships tell us about the nature of time requires interpretation. So, does the future already exist? Relativity alone cannot answer with certainty. What it does show is that there is no universal clock shared by the entire cosmos, and no single present on which every observer must agree. The block universe offers one coherent interpretation of that result. In this picture, every event belongs to space-time, while the passage of time emerges from the way conscious beings experience their histories. Other interpretations preserve a growing or genuinely open future. It is also possible that none of our current pictures captures time completely. What feels obvious in everyday life does not necessarily survive at relativistic scales. The seconds passing on a clock feel universal, yet their duration depends on motion and gravity. The present feels shared, yet distant observers can disagree about which events belong to it. Time seems to flow, even though the equations describing nature may contain no moving boundary between what is real and what is not. We experience reality one moment at a time, and perhaps that is the only way a conscious mind can experience it. The universe described by relativity, however, does not divide itself neatly into what has vanished, what exists now, and what has yet to become real. The past may still have its place in space-time, and the future may have one too. In that picture, the present is not a boundary advancing through the universe. It is simply the point along our history from which we are looking.